Hello, everyone. Today, I want to talk about how we can send all the conversation history to an LLM when we're making a chat application and making sure that we don't go over the context window length for a particular model. So let's dive into this. Okay, so as usual, I have a few example apps that I'll, be using to talk through this. So this is the Azure Search OpenAI demo. And then I also have running right now this new repo that I've been working on, RAG on Postgres. They look pretty darn similar since they have the same or very similar front end. But the difference is a RAG on a Postgres database versus RAG on Azure AI Search for searching documents. And here you can see I'm using the chat tab. And in the chat tab, that supports what we'd call a multi-turn conversation. Multi-turn conversation meaning that the user can keep asking questions and the user has the expectation that we send, that we're sending, the previous information to the LLM. Let me open it up in a new tab just so we can, start from beginning here. So let's say I ask this question, what does a product manager do? So here, this is the first question in a conversation. And here we get the answer streaming in. I'm actually going to turn off streaming just for reasons that you'll see. I'm going to open up the console as well so we get the networking tab. Okay, now if we look at this and we can click on this thought process, which just shows us some information about what happened along the way. So this, we first use the user question to do a little query rewriting. So we asked the GPT-3.5 to turn this query into a good search query. So it turned it into product manager responsibilities. And when we do that, we pass in the whole history. And we'll see that's actually pretty helpful. Then we get back the search results from Azure AI Search. So here are a bunch of chunks from our documents that match that question. And then we ask the LLM to answer the question based on the sources. And once again, we also send the history there. So what happens if I then write, what else do they do? So this is a question that is referring back to the first question without specifically saying, what does a product manager do? And, because we're you referring to a previous concept, this is why conversation history is so important for both calls to the LLM, right? Because you see it actually answered it correctly about a product manager. So what we can do is look in here. The first step is that prompt to generate the search query. And this is actually really important because you see once again, it turned it into the query product manager responsibilities. So that's really good. If we had just directly sent this search query into our search engine, what else do they do? We would have gotten nothing, right? Like that has no meaning. But the LLM was able to figure like, oh, okay, what they're actually looking for is product manager responsibilities, right? So that's the search query it gets and, pulls the search engine again and then sends it to the LLM, and presumably the LLM is, answering things that it didn't mention as much in the first one. So it's really important that we send the conversation history both times. Now, here's the tricky thing, is that our models have limits, right? So let's see, OpenAI models overview. And let's look at so right now we're on GPT-3.5. And if we look at the context windows, we can see their context windows they started off as 4096. And now they're up to, I guess the default is actually 16,000 now, which I didn't realize that even for 0125. So now I'm actually curious. I don't actually know whether I have a 16K context window or a 4K context window. So actually let's look that up. So I'm just going to check my environment variables to see which deployment I'm using, GPT-Viz2. So that would be over here. I'm going to check out my Azure OpenAI service. Is this one? Okay. All right. Because now I'm curious to see whether I'm working with a 4K limit or a 16K limit. And I should be able to see that if I look up my deployments in the Azure OpenAI portal studio. So let's go to Azure OpenAI Studio. And see what our deployments say. So we're going to go to deployments. And we're using this chat model. It's 0613, which I think actually means that, let's see. So we see the version is 0613. The rate limit, that's our rate limit. Interesting that it doesn't show us the capacity is just how many things we can use. It's not showing us the context length for that. Let's see if it's listed here. Nope, also not listed here. So maybe we have to actually look at the documentation and confirm the context windows here. Okay, here we go. So GPT 3.5 models, 3.5 Turbo. Okay, so here we go. 3.5 Turbo 0613 on Azure OpenAI is 4,096 tokens. Okay, so that's what I thought. On Azure OpenAI, if you do want the 16K version, you do explicitly need to ask for GPT 3.5 Turbo 16K. And I'm using just the GPT 3.5 Turbo, so that means that I have this 4,096 tokens. Yeah. All right. So one thing is knowing, what can our model withstand. So that means when we're sending in, all this stuff to the LLM, if we send in too much, we can actually get an error because we've gone over the token window. So I have in this window here a really, really long thread because my goal is to try to get over the context window. And I've actually started writing it in Spanish instead because in different languages, the words require more tokens. So my colleague Anthony has a fantastic blog post about that where he analyze the token ratio. So here you can see like Spanish has a 1.32 token ratio, right? So that means on average it takes 1.3 tokens for a Spanish sentence has been translated from English. If you look at, Chinese, it's like it's looking more like 2, and Japanese can go really, really high on the extreme end here. So I'm trying to go over that token window. So what I do is I've got the network tab open so I can monitor the requests. So let me ask another question like ¿Qué hace un CTO? And I'm waiting to see what the tokens are in the response because I'm trying to get up to 4K because I want to try and go over. Okay, so I am currently at 3,200. So, and I turned streaming off on purpose because if you turn streaming on, you do not get this usage back. We don't yet have usage data available with Azure OpenAI, or I think even OpenAI.com, if you're using streaming. I'm hoping they add that in the future, or I guess that we add it in the future. But currently, you only get back the usage details if you're in non-streaming mode. So if you are interested in seeing how many tokens you're using, you'll probably want to turn off streaming or use tick token to calculate it, which we'll see soon. So I'm currently at 3,200. I'm just gonna, at this point, I'm just gonna paste just lots of stuff in order to try and, go over that limit. So I'll just paste this as my whole, question to keep using up those tokens. Oh, come on. I'm just gonna paste it a bunch of times. Okay, here we go. Oh, I think we might even limit this box to 1,000. We were trying to help people not go over the token limit as well, but we should probably get rid of that. All right, let's see what we're at right now. And we're actually, this time I got a low tokens, because this is also including the sources that we get back. So if we don't get many sources, we don't go over it. So it's it's actually a little hard to go over the context window in there, but we should be able to do it. So I'll just keep asking. Okay. And I see that Sarab is interested in implementing chat history. And John apparently has a question that he'll hoping gets answered. So we'll see what we end up talking about. Let's see. What are we at? Oh my gosh. It's getting less. Am I sending in less now? No, it just depends on what it gets back from the answers here. Okay. So yeah, so we could look at this particular one to see, everything we're sending right down here, right? So we've got, here's the system prompt. Oh, it's actually working. Okay, great. So what you can see is that it's actually not sending the whole history. It is only sending what fits inside the token window. So that's why I haven't gone over the token window, because we're only sending what will fit. So this one starts off at write a 5-stanza poem about CEO roles, even though my conversation started much earlier than that. So that's what I wanted to demonstrate, is that when the user starts having a long conversation, we need to truncate that conversation somehow when we send it to the LM. Otherwise, we'll get an error and the user will not get any answer at all. So the question is, how do we truncate that conversation? There's actually two general approaches that I've heard of so far. One approach is you could actually use an LLM to summarize the entire conversation history. And that's really interesting. I don't know how to implement that in a way that doesn't significantly add to latency, because that would be another LLM call, but I have heard that people do that. So that's a possibility. What we do is that we attempt to count how many tokens, each of these would take. We're like, okay, that would take 10, and that would take 100, and that takes 200. And basically, we start with the system prompt. So we always have the system prompt, always have any few shot examples, always have the most recent user question. So we're always going to have this one here. And then we go backwards from the previous questions and see which ones we can add until we go over that max tokens. And we just keep going back until we've, reached the max. So that is implemented in this Python library here that I've extracted out of our code so that I could use it across multiple repos now. So what I've got in this, in this library here is the, message builder function, or build messages function. And it takes in the model, it takes in the system prompt, the new user message, like the most recent user message, the one that definitely needs to be there, the past messages, the ones that you hope to include but may not be able to include all of them, any few shot examples, and we currently always include those, max tokens, and then whether you want to fall back to defaults in case we don't recognize the model. So this is built for OpenAI models, but I also wanted to be able to just quickly switch over to like a local Llama 2 model or something. So in that case, I use this fallback to default. Because what happens is that the first thing we do is try and figure out what the token limit is for the model. And we also try to figure out the encoding for the model. And I know all of those things for Azure OpenAI and OpenAI models, right? Like I know these token limits, and I can figure it out for those, but I don't know it for, some random small language model that you're running locally. And then I can count the tokens for messages using the tick token package. So the tick token package is from OpenAI, and it implements their tokenizing. And basically all the recent models use the CL100K base. Now this might change in the future as they add more, more models, but currently all the ones that I, am accounting for here all use this CL100K base. But they do also have this function actually encoding for model that will, look it up, right? So you can actually see here, right? All of these are CL100K base. So the older ones, like way older ones, used a different one, but I don't think anyone is using those anymore. So we get the encoding for the model, and if we're using a small language model locally, we can just pretend we know the encoding and hope. If you're actually using small language models a lot, then you can use instead a Hugging Face tokenizer library. And there's effort, people are working on that. So, probably use a different thing, not use this. And then we start calculating how many tokens are taken up by a chat completion message. So there's different amounts of tokens. Like there's a standard amount of tokens just because like the actual message that comes out is, something like, like this, right? So we have to account for how OpenAI takes our messages and turns them into tokens that it actually feeds the models. So this is actually documented on the OpenAI site. So this is just based off their documentation, because this is all internal. Like internally, OpenAI takes our messages and it, adds 3 tokens per message in order to be able to format it. And then we have this, code here that would go through and figure out how many tokens each message takes. If it's image for GPT-4 Vision, then we figure out how many tokens an image takes. And yeah, and we just go through everything in the message and figure out how many tokens a message takes, right? So then we can count the tokens for this particular message based off of this, this algorithm here. And then going back to our message builder, we start off with the system prompt. Then we insert any few shots. Then we insert the user message at the end, the new user message at the end. And then we go backwards through the past messages and try to add those past messengers to the new collection of messages until we get to a point where we would go over the max tokens. So we just don't add that message, and then we, break out and return back the messages we came up with. So that's that function. So then we can, use it, in our repos. So I'm using it in here, right? So pass in my model, my system prompt, the few shots, past messages, new user message. And I also pass in max tokens, because here's the thing is that when they say there's a limit of, 4,096 tokens, that's actually for both the input and the output. And I even double checked that this morning because I wasn't 100% sure, like, is it really? But yeah, it is for the input and the output. So that means when you're trying to fit the messages in, you want to consider how many tokens the response could take up. Now, fortunately, we always set max tokens on our response, right? So in this case, I say, okay, the maximum tokens my input messages could take would be the limit of this model minus the max tokens of the response, right? So for the query, that first LLM call, we ask for just like 100 tokens as a response. So it gets to use up almost all of the token limit for that model. But then for the later one, I have a token limit of a 1024 because you could have quite a lengthy response. And so that means that it's only going to have, 4,096 minus 1024, right? So it'll have less. And that's actually why we saw that makes sense. Yeah, that's why we probably saw that our token usage didn't, get up to 4,000. So that's the general strategy. Now, is it perfect? No, because we are using function calling. And function calling, I have not accounted for in our calculation yet. We actually pass functions in separately from messages, right? We pass them into this tools parameter, but they do require tokens in the input. And there are so many threads where people have figured out in the OpenAI forums, like exactly how many tokens it takes to encode a function, right? Because it doesn't get turned in, like, it's not passing exactly this JSON here. It's, turning it into a particular schema. It's surrounding it by other, function things. So I have found, let me see, like this one, there's lots of folks who have, made an attempt at counting tokens for functions. This is one I found, this Python library. Now, unfortunately, this was made 7 months ago, and since then they actually slightly changed it. And that was when they changed from functions to tools as a parameter, and it hasn't been updated for that. I found a diff where somebody converted Java code to do this, to work with tools. So, it is possible to update it for the new tools, but this one hasn't been updated. So I don't know if any of the Python packages for counting the tokens that functions take up are actually currently accurate. So I might end up just implementing it, by looking at both this one and the Java version, and then of course verifying it. So let me show you how I verify things right now. So in in the actual package here, I have all these example questions. And so they have things like, I have system messages, I have user messages. I've got, user messages that have particular things like text and images, right? And then what I do is I actually run all these through OpenAI, and I look at that usage to verify that the amount of tokens taken is what I expected based off what I passed in. So this is how I'm trying to make sure that this is actually accurate. Because we're doing this based off of documentation and cookbooks and random things that people figured out on forums, and it's we want to try and get it 100% correct. What would be lovely is if the OpenAI SDK provided this, and I have filed requests on the on the SDK repo, because I would love to just deprecate my my package here and just be like, yay, we get to use the SDK. But until that happens, we'll keep working on the package. So let's see. Question from John. Do I have a clever way of sending the chat history back and forth? Or are you just adding the latest messages and making a new request at endpoint with a full conversation? Yeah, that's a great question, because, right, we have a stateless application here. So what do we actually do? We just store everything on the client, and we send back, we just, there we go, messages, answers. Okay. Yeah, so we have this answers array. Probably just look at the top here. Okay. We have this answers array in the TypeScript here. And we're just continually adding to that answers array as we get responses, and then we send those. If we look at messages, right, we send that in the messages list. So we see messages, yeah. So that's what we're doing, is we're just storing it in the client, and we're sending it. I guess the question is, are we sending it back and forth? We can take a look at the response that we get back for any particular, any particular thing here. So we get back choices, and we add to this with some things like data points. So that's the citation. This is the thought process. And here's the response, but we're not sending it back. I'm just double checking to make sure, but yeah, we're not sending it. We're not sending that history back. We're just storing it in the client. Now you could send it back. I heard, I think one of my colleagues was arguing for doing that. Is always sending that back and forth, because that would maybe be a little more robust. So I think that is a possibility. But right now we are just storing it client side. Yeah, so John said I was thinking of using something like Flash sessions to store it. Yeah, and at that point we could also talk about, like, and some of you might be watching hoping I was going to show how to do persistent conversation history. And I have not implemented that yet. There is a PR that adds it to the Azure Search OpenAI demo. This PR currently can't be merged because it was done way back in June. Gosh, it's been nearly a year. Crazy year. So we could look to see how how they did it. Are they sending it back and forth? This is a long PR, so I need to read it here. But yeah, so they're tracking a conversation ID. Luckily, we do also have a user ID parameter, so I think we're in a good place where we could put this because we have user authentication optionally now. And then they've got all these routes for adding and retrieving a conversation. So that would be another approach. Like, because as long as you're going to go through the effort to have sessions, you might just want to have persistent history, because then you could go back and a user could, look at their previous conversations. And so in this case, I think they're basically kind of making like threads of conversation, because like you can do add and read and list. So it sounds like, each session would probably add a new one. I guess if you wanted to be more lightweight and just, just remember it for that session, then maybe flash sessions is a nice in between. The other thing you could do is, use local storage on the browser. If you were just trying to get something that, stayed around for a little bit, but maybe didn't have to stay around forever or necessarily work across multiple computers. I'm a big fan of local storage, but of course it's not ultimately persistent. So if you do want persistent conversation history, you could take a look at this demo. You could also take a look at this repo here, which does have conversation history. Actually, if we can just look at the blame here. Chat history feature. So you can see how they added chat history. They're using Cosmos DB, and they're, getting the authenticated user details. They've got add, insert, delete. So I think it's actually really similar to the other one, but I haven't looked into either of these in detail. So, I don't have an opinion about or knowledge about the, the difference between them, but they look pretty similar. So that's what I would suggest looking at if you're looking for a persistent conversation history. And either way, you still will ultimately want to use this approach of making sure that you're not sending too much history to the model. But if you are doing persistent conversation history, then maybe that opens up more options for doing interesting things like using the LLM to summarize that history, because you could even do that offline. And then you could actually do really cool things like using the LLM to do like entity analysis. Like I was talking with somebody who was like, like an LLM should remember when you said that your mom's dog is named Shelby, right? And you could remember that if you did, use an LLM or another model to do entity analysis on past conversations and just said, hey, like extract all the key facts from these conversations that we might want to know in the future. So that would be a really cool, way of equipping the LLM with more information. And so this seems particularly useful for stuff like ChatGPT, which is very like personal, user-facing experience. It could also be useful for these kind of like enterprise chats, because maybe you do bring in some personal details into it, but probably not as absolutely useful as it is with ChatGPT, where you want the LLM to remember the things you said before. And it's not that the LLM is remembering, it's that you're somehow storing that and then feeding that back to the LLM. All right, so let's see. I have a question that you can help answer. Is there a way to make the chat app actionable, like sending emails, etc.? Yes, you could. I always worry about something like sending emails without like a human approving that. I would get worried about that, but I guess we already do that to some extent with like our home assistants, but I don't think they do a very good job. Like my iPhone keeps on thinking I'm talking to it because I named my kid Sierra and it sounds a lot like Siri, and now it's probably going to hear me again. And so it's always trying to do stuff. I'm like, no. So anyway, yeah, I think you could do that. I think you'd want to, use the technique I've, talked about with, basically you want some form of function calling or, or structured output, right? So here we're using function calling for just query rewriting. And in the, the RAG on Postgres example, I use it also to come up with SQL filters. So you can, you can use LLMs in order to figure out, the intent of a query, how to route a query. It's called lots of things, in the, in LangChain and Llama Index and in the research and stuff like that. But we're basically using the LLM in order to, uh, you know, introduce a decision flow as to what we're going to do next, right? So in this case, I'm using function calling in order to generate the optimal search query and also the optimal filter to add to that search query, right? We can also use it. Let me actually, this one's probably more similar to the sending an email. Let's see if I can find it. Escalate. Let's see if that's gonna find it. Here we go. Nope. That found a lot. Let's see, function. Yeah, okay, there's one, but I'm looking for Tony's. How do I do an author parameter? Let's see. Okay, here we go. Here we go. I just need to make a list of these. Okay. All right, so here's another example I did where if you wanted to like search by a particular file name, so that's kind of similar to that filter, the SQL query I just showed. This is one that Anthony prototype where you're trying to detect that the user is getting mad and then escalating, giving them information about how to escalate to a real person. And here we can look to see the function, that we pass in. But all of these are the same ideas that we're using function calling in that first phase, which currently we use for query rewriting, but you can also use it for routing, right? So you would add a function like send email, and then depending on what the user wrote, you would either do a search or send email. So you're basically looking for routing. You can also look to see, if you're comfortable, you'd rather use packages. You could look in like Llama Index for routing. Yeah, I think that's what they would call it. That's the general idea of it. Jerry Liu also, let me see, can I find his Jerry Liu's the founder of Llama Index, and he gave a talk that I saw last week called Beyond RAG, and that was really nice. I don't know if he's linked the slides yet, because he talked about all this stuff. Let's see. Slides. Okay. Oh, there we go. Great. Okay. I'm going to retweet this. So we look at this presentation here. So he calls it Beyond RAG, and it's going beyond the basic RAG that you might hear of, but we already do some of these things in our repos as well. But there's some really nice ideas about how you can think of your RAG in terms of being more of an agent and how you could use that for doing more planning and for using more tools. And the basic point is that you do need to have, you have to have multiple LLM calls, right? You have to have this initial LLM call that's going to figure out what's the next thing to do and, come up with a plan. And then your subsequent calls might involve searches. They might involve probably another LLM call. And here's where he talked about conversation memory. And so he's talking about, you could do you could condense things here. Here's where you talk about query planning. If you needed to do parallel queries, you could, do calling tools like text to SQL. That's kind of what I was doing. And then you can put them all together. So yeah, agent reasoning. So we get a new message. We fetch the conversation history, store it, figure out what we're going to call that, and then decide whether we need to call anything again or return. So this is a way of, that you can think about it more abstractly, and you can find stuff like in Llama Index and LangChain for doing this. I tend to just use function calling, for this. And I think behind the scenes, Llama Index and LangChain are basically implementing this with function calling because it's the currently the best way to get, a structured output and get an LLM to make a decision. But I think this is a nice way of, thinking about it and just seeing what, what ideas there are out there. So yes, you can make it actionable. I would always recommend having a human in the loop. Like maybe you show, here's the email we're going to send, and click this button to send it. I think that would be a good thing to do. Especially if you're sending on behalf of the user, for sure. Cool. All right. Any additional questions? If you're interested in the library, you can grab it from pip, OpenAI Messages Token Helper. This is in Python. If you are using a different language, I found that there are token counting packages in lots of languages. I found Java and JavaScript and Dart. I don't know if any of them exactly implement, like the build messages thing, but the algorithm is, pretty straightforward. So you can just write that however you'd want to write that, or just copying this one. So there you go. All right. Thank you, everyone. Have a great weekend. See how, where do I go? Say bye to the gray fox.